All right, so begin by turning your graphing calculator on if it's not already on. Locate the program button, which is right here. Look at the screen. Look at my projection. I have an arrow pointing right to where it's located. I think Mr. McCaskey made this for us. When you press the program button, you should get a menu that looks like this. I need you to tab over to the New tab. See at the top where it says New, use the left and right arrows to move over to the New tab. And where it says Create New, press Enter. It should now give you an option to type a name. I'm going to name mine Quad. You can name yours similarly or whatever you want. You could name it Hubert if you please. It's up to you. Huh? I don't know what you're talking about for sure, but this is a program that's going to run. It's going to do things. We're programming our calculator. You would lose this. Put it in. Okay, can we please focus and leave all the non-related questions except for what exactly we're doing right now. And we'll get to all the little what-ifsies at the end. What I need everybody to be doing right now is trying to do this. So I named mine Quad. Once you've finished, go ahead and press Enter. And it should now look like this, where it says Program Quad and there's a colon on your screen. Should look something like this. Is everybody there? We should have named our program. And now we're going to write our own program. The first thing I'm going to do now is I'm going to press the program button again. What that's going to do is it's going to open up a menu that looks like this. Is everybody at this menu? Okay. What are you confused by?
Wait, I just made a program back.
See the screen on the side is what your screen should look like right now. Okay? What we're going to do is we're going to move over to the I/O tab, and you're going to select the Clear Home command. So you moved over to the I/O tab, and then you're going to select the Clear Home command by pressing Enter. So your screen should now look like this. Keep scrolling. What you need to do next, stop talking please, is we're going to press Enter again, so you move to the new line, and you're going to repeat the process by pressing the Program button, moving over to the I/O tab, and this time selecting the Prompt command, and then typing the letter A afterwards. When you've got a screen that looks like this, look up at me so I know it's time to move forward. You press Alpha, and then you find the letter A on there in green, and you press that button. I think it's right below the Alpha button. You're in the wrong menu. You need to go back into the program. Press the Program button. And then go over to Edit. pick your program, and then you're back in there, and then you just need to repeat those steps. All right. Once you have prompt A in, go ahead and press enter to move to a new line. And you're going to repeat that same process to have prompt B and then prompt C. So when your screen looks like this, where it says clear home, prompt A, prompt B, prompt C, look up at me. What we're doing right now, the prompt command, what the calculator does when it runs this program, when it comes to the prompt, it's going to ask you, the user, to input a value for A, B, and C. What we're doing right now is writing a program to calculate the quadratic formula for us. Okay? So the first thing we need to do is be able to enter in the values for A, B, and C into our calculator. So that's what the prompts are doing. It's asking us, whoever's running the program, to enter in some numbers for those. Okay? Next step. So I've typed in prompt C and I pressed enter, so I'm on a new line. What I'm going to do now is type in the quadratic formula exactly as I've written here. Move up.
My calculator is so different and none of this is working.
So I'm here, and then what do I do next?
Press enter.
And now type that in?
Yep.
Okay.
Okay, see, my thing's not very smart. Am I gonna get a completely different calculator?
Oh my
And, like,
goodness.
I'm kind of just stuck here, and I like kind of made the program, and I don't know what to do next. I'll get a new one. I'll come back tomorrow.
Okay. I'll post the PowerPoint here that we're doing to the class page as well. So if you do get a new calculator, you can try working through it at home.
How do you get the line then? How do you get the arrow to point at B?
So the question is that Nick asked is, how do I get this arrow? I'm going to press the STO button, which is located right there. Now, so when we are typing this in, it's very important that it looks identical to what I've typed here. It's this STO button right here to get the arrow. Okay, so make sure you have the time symbols where it says time symbols. You have all the exact same parentheses and the same number of parentheses. It should be identical to mine. The arrow key is the STO button here at the bottom, above the on button. That is a D. The letter D is at the end. The arrow is the STO button above the on. Okay. The next line. You're typing the exact same thing, and the only difference is where there was a plus, we're now going to type a minus, and we're going to stow into an E instead of a D. What are you looking for, Olivia? That's the division symbol. So just press the divide button. That's okay. You're new to the calculator, so It's above the on. Nope. There's some more stuff still to the program.
Yeah, but like, will we need to come up here?
You should not need to see any more than that. That is a negative sign, not a subtraction symbol, though. On the b. As opposed to the one between the b squared and the 4ac is a subtraction symbol, not a negative. So just to rehash what we've done so far, the prompts allow us to input values for A, B, and C. The next two lines, we use the quadratic formula to calculate the two answers, and we're going to store those answers into the variable spaces D and E. What I want to do next is display those values for D and E. So what I'm going to do is press the program button again, move over to the I/O tab, and this time select the output command. And I'm going to type in the number 6, 1, and then the letter D. What the output command is doing is giving the calculator, or telling the calculator where to display this value. So the 6 is the row on the calculator that it's going to put it, and the 1 is the column it's going to put it. So it's going to put the answers down at the bottom here for us.
I just did my entire stack.
No, you didn't. Press the program button. Press the program button. Go over to Edit. Press the program button. Go over to the Edit tab. At the top, there's 3 options. Find the Edit tab. Press Enter on Quad. And it's all there.
Something that I did, since I accidentally deleted like half the stuff.
So you can't recover the deletes. So you just have to go in, and if you press like, yeah, there's not like a way to copy and paste or anything. You're just going to have to retype this line with the subtraction symbol and then the outputs, unfortunately. That you can't fix. Okay. One more step. Is press the program button one more time. From the CTL menu, scroll all the way bottom and find to the bottom and find the stop command. And your program should then look like this. Once you've done that, go ahead and exit out by pressing second and mode and wait for everybody to kind of catch up. Stop. What are you asking, Michael? I'm sorry. Get stop. So you press program, scroll down to the bottom to find the stop command. And once you have the stop up there, you're finished. So you can exit out of the program and we can start running it and testing it out to make sure that ours works. Andrew? We are done with it. Once you have the stop command in there, press second and the mode button and it'll take you back to the home screen. You can exit out of there now once it's all written. Even if you exit out, you can always go back in and change things. It doesn't go away. We've written this program. It's now recorded in your calculator as a program that you're going to use. If your program happens to get deleted, if somebody clears your calculator, if it runs out of batteries and the memory gets erased or any of these things, I'll post this PowerPoint to PowerSchool.
Mr. Littleton's our calculators after every test.
Shh. I will post this PowerPoint to PowerSchool and the video that we just walked through, and you should be able to redo that. All right, what I want you guys to do, stop talking, please. Excuse me. Stop talking, please. I want you guys now to take out your assignment from last night. We're going to use our new program to check some of our answers. So, what I need you to do is the ones that you wrote in standard form that are obvious candidates to do the quadratic formula on. I want you to try to run your program and have it work to check your answers. That is exactly what this is doing.
We click program quad, and then we just type in the equation.
So you press enter now to run the program. And when it prompts you for the values for A, B, and C, you enter your values for A, B, and C. So, if you go find your program in your program menu, you press enter, and then press enter again to execute the program. It should then say A with a question mark. So for number 2, for example, if I type in 4 is my value for A, 0 is my value for B, and -9 is my value for C, I press enter, and it spits out my answers, which are 1.5 and -1.5. Pretty sweet, right? Yeah, let's do it again. Which one do you want to solve? 12. Okay, to do 12, it has to equal 0. So the first step I would do is subtract the x from both sides. When I do that, I'd have 6x squared plus 0x minus 24, correct? So the A is 6, the B is 0, and the C is -24. I press enter, my answers are 2 and -2. Let's do another. Let's check, say, 8. So the first thing I need to do is subtract the 3x from both sides to give me 4x squared minus 3x plus 10. So if I run that program, A is 4, B is -3, and C is +10. And I press enter, and it says non-real answer. What does that mean? It's more than just not factorable. Let's look at what happens when we do this one algebraically, when we try to do this by hand. Okay? So when we try to do this by hand, let's observe what happens. So we had 4x squared minus 3x plus 10 equal to 0. So when we do the quadratic formula, I have -b plus or minus b squared minus 4ac all over 2a. So negative of a negative is positive. Stop talking, please. -3 squared is 9. Negative 4 times 4 is negative 16, and times 10 is negative 160, all over 8. 9 minus 160 is negative 151 over 8. And what is the square root of negative 151? Can we take the square root of a negative number? No, right? So that's why the calculator is telling us we have a non-real answer here. Let's fix this. We should like to be able to solve any quadratic equation, correct? So what we're going to do is we're going to extend our set of real numbers that we've been working with and create a new set of numbers that will allow us to do this. Now, when I say that, you're going to think that's like a bunch of baloney. You can't just do that. And I'd be like, my answer to you is, oh no, we've done this many times already in your mathematics career. You just didn't notice us doing it. In elementary school, you did this at least 3 times. So in elementary school, what are the first numbers you learned? The counting numbers, right? And the next thing you learned after you learned how to count was probably adding, right? And there's no issues when adding counting numbers. You just get another counting number back. But then you learn subtraction. And what can happen if you subtract 2 counting numbers? You can get a negative. So we had to extend our number set now from just the positive numbers to include the negatives also. Because we got to a problem that we couldn't do with the numbers we were working with, so we extended our number set to be able to solve that kind of a problem. And that was fine for a while, and you went through a couple of grades of elementary school, and eventually the next thing you started talking about was multiplication. And everything was fine. You can multiply any positive or negative whole number you want. But after multiplication, you learned division. And what can happen there? Not every positive whole number can divide another whole number, because you sometimes get a decimal, right, or a remainder. So what did we do? We extended our number set again to include the rational number, so you can get a fractional answer. So you can say, like, 15 divided by 4 is 3 3/4, you know, like that kind of thing. And that was fine for a while. And eventually you start talking about things like square roots. And again we had to do this, because if I take the square root of, say, 2, I can't write the square root of 2 as a fraction. It's a whole separate kind of number that can never be written as a fraction, and it's not a whole number. We needed to add another set of numbers in there. Those are called the irrational numbers. And that new set of numbers we called the real numbers, and that's been fine for a long time. But now we've arrived at this problem that we can't deal with, so we're going to again extend our set of numbers. Is everybody okay with this idea and feels less fishy than when I said it originally? Like, okay, I see we've done this a bunch of times. This is just what we do in math. And it is. So the idea here is we're going to define the following value. I'm going to say I is equal to the square root of negative 1. So we call I the imaginary number, and we just call it imaginary, not because it's made up, because really all numbers are made up. It's not any more made up than the number 7 is. But along the way, we called the previous set of numbers, we're working with the real numbers, and by convention, we're going to call this the imaginary number because it's like separate from the real numbers. It just kind of makes sense from a verbiage standpoint. But you could have just as easily called these the, like, taco numbers or something. It's the name imaginary doesn't mean it's made up any more than any other number is made up. Okay? So we're going to call the square root of negative 1 I. And if we form the new set of numbers, a plus bi, where a and b are real numbers, and I is this square root of negative 1, we're going to call this set the complex numbers. and we can solve any polynomial equation over the complex numbers. So the problem that we just tried to solve that had no real solution, it doesn't if we're only giving answers in real numbers. But if we're going to allow for a complex number solution, we can certainly solve that equation. And we'll show you that in just a moment. Let me spell out a little bit of this notation here because I've written some symbols here that maybe we don't know what they are. So this symbol C, with the line down the middle, is just the set of complex numbers. So it's just the name that we give to that. This symbol here is like a curvy E, just means the words is a member of. Let me draw this a little bit better. This is like the letter R with two vertical bars. This is the set of real numbers. And remember what the set of real numbers is any number that can be represented as a decimal. So anything that we've talked about at any point in any of your math classes up until now have been real numbers. The counting numbers are real numbers. The fractions are real numbers. Square roots are real numbers. There's other things that aren't square roots that are real numbers. So any number that you could write as a decimal, whether you need any decimal points or not, is a real number. Now we're going to add to that these complex numbers that have a real part and this imaginary part. So when we introduce a new set of numbers, the first thing that you'd want to ask is, okay, well, like, how do I add, subtract, multiply, divide with this new set of numbers, right? When you're introduced to fractions, that was the first thing that you needed to do, was to deal with, okay, how do we add or subtract or multiply or divide fractions? Or decimals, right? So let's look at some examples. So we're just going to play a little bit of a game here. I'm going to ask first, are these things complex numbers, yes or no? It is. Well, I should be able to write it in this form. Well, 6 I can write as 6 plus 0i, right? That's a complex number. How about 4/3? Is that a complex number? Yes. How can I write it? 4/3 plus 0i. Is 6i a complex number? Yes. I can write it as 0 plus 6i. Is 3 minus 2i a complex number? Yes, definitely is, right? That's my a plus bi, right? Definitely in that form. It's easy to see that one. So what is the kind of conclusion here? Everything is a complex number, right? So everything that we now have talked about, whether it was the numbers you learned in elementary school, to these new imaginary part numbers that we've learned now, they're all in the set of complex numbers. Everybody's okay with that idea? They're all there. Okay. So, the first thing we'll talk about is adding two complex numbers. So what if I have the complex number 3 minus 2i, and I want to add it to the complex number 5 plus 6i? How would you hope that we add these things together? Yeah, how would you want them to add together? Exactly the way it's going to work. So we're just going to add the real parts together, 3 plus 5, and add the imaginary parts together. Negative 2 plus 6 is 4, and then we'll just keep the I. Oh, well, that's really nice, right? Exactly works as we'd hope. Nothing tricky about that. It's basically just combining like terms, right? Non-i's get grouped together, and the parts with the i's get grouped together. Easy. Everybody okay with that idea? What about subtraction? What if I wanted to subtract those same two numbers? Oops. If we think about what is our definition for subtraction that we use in just everyday math? It's like adding a negative, right? We can use that. We've used that when we did the factoring, right? We took advantage that subtraction is the same thing as adding a negative. That's what I'm going to do here. Oops. And what do we do when there's a negative sign in front of a parenthesis like this? It distributes in, right? And now it's just an addition problem. So 3 plus negative 5 is negative 2. Negative 2i plus negative 6i is negative 8i. Again, hopefully that's what you would have hoped, right? That wasn't bad. All I have to do is distribute the negative sign across the complex number and then add them. Yeah. NBD. What if I wanted to multiply these two complex numbers together? How would you hope this works? Yes! We would hope that we would just have to FOIL this, and indeed, that's all we're going to do is FOIL. So, first is 3 times 5. Outer is 3 times 6i. Inner, negative 2 times, or negative 2i times 5 is negative 10i. And then lasts, negative 2i times positive 6i is negative 12i squared. Everybody's okay there? So if I combine my like terms, I would get 15 plus 8i minus 12i squared. But what does I squared mean? Let's think about that for a moment. So I'm going to head back up to something else here. So if you're writing, hold on, I'm going to come back down to the bottom here, but I'm going to scroll up for a minute. I want to go all the way back up to here. If I is equal to the square root of negative 1, I squared would be the square root of negative 1 squared, right? And if I square root if I square a square root, I know those should cancel, and I'm left with negative 1. So I'm going to say that I squared is also equal to negative 1. Is everybody okay with that as being a direct consequence of our definition that I is equal to the square root of negative 1? Sure. Nick?
So would negative 12 multiplication become positive 12?
We're going to get back down there and use that fact in just a second, and yes, that's exactly what's going to happen, is that we're going to substitute in the negative 1 for the I squared, and that minus 12I squared is just going to become plus 12. Jordan, you good? Okay. We're going to scroll back to the bottom, and now that we've established that I squared is equal to negative 1, I'm going to replace the I squared with a negative 1. Negative 1 times negative 12 is positive 12. And then 12 plus 15 is 27. So I get 27 plus 8I. Note that our answer here is once again a complex number, right? We should not multiply two complex numbers together and get something that's not a complex number. It needs to be something that can be written in that A plus BI form. Is everybody okay with that idea? All right. Here's the one nobody likes. Division. Yes. So 18I minus 10I is 8. Yep, that's okay. Yeah, I maybe picked some poor numbers for that, but so we're going to do multiple examples here because the division can run the gamut from being something that's relatively easy to something that's not so easy. So I'm going to start with something that's not quite as difficult as we had before. Let's just say we're going to divide this complex number by something with no imaginary part, like the number 3. So all I'm going to do is I'm just going to write this as 3 divided by 3 minus 2 divided by 3, or just really 1 minus 2/3 I. That's easy, right? If I'm just going to divide a complex thing by a real number, you just write it each as a fraction and reduce if you can. Now, let's say I want to divide it by something that's a purely imaginary number, like 3I. Well, I'm going to think about this the same way. I'm going to think of it as 3 over 3I minus 2I over 3I. So 2I over 3I, we can reduce those i's, right? Is what we have now a complex number, though? It's not written in the form A plus BI. Mostly the issue is that my I is in the denominator of my fraction. So what I'm going to do to get the I out of the denominator of my fraction is to multiply the top and bottom by I. Let's see what that does. So 3 times I don't know what, anyways, is 3I. And 3I times I is 3I squared. Everybody okay with that? And what's the advantage here? I squared is equal to -1. And I guess we can reduce those 3's. We could have done that a long time ago. So I over negative 1 is just negative I minus 2/3. And there is now a complex number. So this action right here that we're doing to get the I out of the denominator is called multiplying by the conjugate when we do that. Now, when you have a purely imaginary part as your denominator, that's not too difficult. Let's look at our final, most difficult case. So when I have complex divided by complex, what's up? Are we on E? Oh, C? Okay. All right, my apologies. So what I'm going to do is I'm going to write this as a fraction to start with. Everybody okay with that? And what I'm going to do now is I'm going to multiply by the conjugate of this denominator. What is the conjugate of 5 plus 6i going to be? It's going to be the same thing, except the sign in the middle needs to be the opposite. So I'm going to multiply the top and bottom by 5 minus 6i. And you'll see why this is going to work in a moment. Okay. But you just need to flip that sign in the middle. If it was a subtraction, we make it addition. If it was addition, we make it subtraction. And now what do we do? Well, I'm just going to FOIL the numerator and FOIL the denominator. And let's see what we get. 15 minus 18i minus 10i plus 12i squared over 25 minus 30i plus 30i minus 36i squared. Take a look at the denominator there. Do you see something nice happening? Yeah, I have a minus 30i and a plus 30i, so those are going to cancel out. And I know that I squared is the same as negative 1. So if I combine my like terms in the numerator, which I also know the I is negative 1, I have 15 minus 12, so that's going to be 3. 18i minus 10i is minus 28i. And in the denominator, I have 25 minus a negative 36, which is plus, which comes out to be 61. Notice in the denominator, no i's, right? So this is now back to the very first example A, where I have a complex number divided by a real number. So all I need to do is just write this as 3 over 61 minus 28 over 61i. And we're done. Unexpected way of having to divide those complex numbers, right? That process was not at all what we would have expected or hoped for division to look like. Although, it's not that bad because it really just boils down to multiplying, right? Okay. So, let's now return back to the very, very beginning where we got that square root of a negative number when we were solving. now that we know a little bit about what i's are. So if I return to this, to finish this out, I know that the square root of negative 151, I can write as the square root of negative 1, times the square root of 151. Everybody's okay with that? And what's the square root of negative 1? That's I. So 3 plus or minus I square root 151 over 8. And that's how we'll write our answer. The question is now, can the calculator do this? What do you think? It can. Let's do that. All right, so here it says non-real answer. I'm going to go ahead and press quit. What I'm going to do on my calculator now is I'm going to press the mode button. You guys should all do this on your calculators. The mode button is right next to the blue second command at the very top. What I'm going to do is I'm going to scroll down to where the option says real. I'm going to move over to where it says A plus BI, and I'm going to press enter so that option is highlighted. I press the mode button, and then I did what I just showed you. Okay? Have you guys changed your mode? It's right here, Jordan. So I'm just changing that option there. It should stay here unless your calculator's reset. That option will stay. I'm going to exit out of here now. And what I'm going to do is I'm going to rerun my program and enter in the values for this polynomial, which was 4, negative 3, and 10. 4, negative 3, and 10. So I'm getting 0.375 plus 1.53 yada 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 I, and then 3.75 minus 1.53 yada 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 I. Notice this number, 1.53 yada yada yada, is exactly 150, the square root of 151 divided by 8. So it is giving me exactly the same result that I just got by hand. Now it's not being so nice as to give me an exact answer with the square root in it. It's giving me this crummy decimal answer. But it's still pretty good that it's giving me a complex number answer. That's still a pretty good deal, right? So now, no more errors when you try to run your quadratic program. The thing you have to keep an eye out for is if you're getting a crazy decimal, is there like an I at the end of that or not? Because you might be getting a complex answer there. Complex number answer. Okay? Good. What I'd like for you guys to do as your assignment, I want you to go back and check your answers for 1 through 14, for all of them, using the quadratic formula. Now, some of those that's going to be a pain in the butt for. Which ones would that be a pain in the butt for? Things like number 7. Why would that be a pain in the butt for number 7? Yeah, you'd have to expand that out to get it to look like a standard form polynomial before you could use the quadratic formula. But that's what I want you to do, is to check your answers on 1 through 14 using the quadratic formula program that we just built. And we'll talk more about this next time. How's that sound? Deal. And I'm done.